Welcome everybody in a new video. In this video I'll explain you how does complex numbers work. And also I'll explain you how to do the for operations with complex number. Before I begin I would like to tell you that if you like my videos you could consider the idea of giving me a like or subscribe to my channel. It is just a little effort for you, but you will help me a lot. Okay, let's begin. So what is a complex number? A complex number is basically a coordinate between imaginary numbers and real numbers. So in this graphic, a complex number could be here, here, or here, or maybe here, here, or here, or here. Okay, it's a coordinate. This is the line of real numbers, and this is the line of imaginary numbers. Well, but what is a real number to begin with? Well, the real numbers, they are all the possible numbers that can exist. Okay, all the possible numbers that, all the possible numbers existing, like +1, +2, +3, but also -1, -2, -3. Okay, these are just some examples. An imaginary number is a number that it technically cannot exist, technically. Let's see some example of imaginary numbers. An imaginary numbers must have two characteristics. It must be negative and it must be under a square root. Okay, so a negative number under a square root. Like this, -3 under a square root, or like this, -4 under a square root. These numbers are logic impossibilities, and now we'll see why. Now I'll tell you why. Let's examine this. Okay, this is just, this is not an imaginary number, this is just square root of 4. Okay? Okay, when you have a square root, you basically have to answer a question. And the question is, what is the number that multiplied for itself gives me the number under the square root as a result? Okay? So in this case, 4. The question is, what is the number that multiplied for itself gives me 4? It could be 2, like 2 multiplied for 2, the result is 4, okay? But it could also be -2, because -2 multiplied for -2 gives me 4, okay? But as you can see here, it doesn't matter if I take the positive number or the negative number. It doesn't matter, because the positive number will give me a positive result, okay, sure. But also the negative number will give me a positive result, because it will be -2 multiplied for -2, okay, and the result is positive. So there is no way that a number multiplied for itself, it doesn't matter if it is positive or negative, there is no way that a number multiplied for itself gives me a negative number. This is impossible, okay? And this is why as a negative number under a square root is like it's impossible, okay? In mathematics, in theory, it is something impossible. It is like a logic impossibility, okay? So they are numbers that can technically not exist. But even if they can not exist in theory, even if they can technically not exist, we really need them. We need them to calculate a lot of things. I know it's a bit weird, I know it's a bit strange, but they are very useful. Even if they can technically not exist, they are actually really useful. Okay, so we use them. Okay, now here we are doing electronics, so we are not doing mathematics, so I'll try to make it very simple, okay? An imaginary number we use in electronic are basically just exactly like the real number, okay? They are exactly the same as the real number, but they have one characteristic. They are all multiplied for square root of -1, okay? So all the real number that exist, just each one of them is multiplied for the square root of -1, okay? Like this. The imaginary numbers could be like +1 multiplied for square root of -1, okay? Or it could be +2 multiplied for square root of -1, or it could be +3 multiplied for square root of -1, okay, like this, in this way. Or it could be -1 multiplied for square root of -1. Or it could be -2 multiplied for square root of minus 2, sorry, of minus 1, okay, or maybe minus 3 multiplied for square root of minus 1, okay? This is how the imaginary number usually works, okay? This is how we usually they are just this, okay? In electronic, when you do, usually they are just this, okay? This is how we use the imaginary numbers. You will never use like square root of minus 4, minus 5. No, you just do this, okay? But you don't write, for some reason, you don't write square root of minus 1. You use another, you do it in another way. Instead of writing square root of minus 1, you just write a j. Okay, the j symbolizes square root of minus 1. Okay, so instead of writing this, you write j, and j is this. In mathematics, usually they don't write a j, they don't use a j, they use a I. But we don't do this in electronic because, you know, in electronics, I usually represents the current. So if you use I, this could be a little confusing, so it's better to use j. Okay, so we use j. And j just means this. Okay, so maybe an imaginary number could be j6, okay, or j4. This means square root of minus 1 multiplied for 4, okay? This one is square root of minus 1 multiplied for 6. These are imaginary numbers, okay? A complex number is a number who has a real part and an imaginary part, okay? The combination of these two. Usually, some example of complex numbers are maybe this. 4 plus j5, okay? This is a complex number, 4 plus j5. Or maybe 2 minus j6, okay? This is another complex number. Or maybe minus 2 plus j6, okay? It could be maybe this is the real part and this is the imaginary part. They are correct. This one could be positive or negative, and this one could be positive or negative, okay? So these are examples of complex number. Another example could be minus 2 minus j9, okay? This is another example. So basically, a complex number, it has a real part and an imaginary part. Okay, this one is the real part and this one is the imaginary part. Okay, but very often you will find some numbers that only have the imaginary part and they are still fine, like plus j6 or minus j8, okay? Well, in this case, we still consider them as complex number. We still use them in, you know, in all the calculus that we'll see later, okay? But we still use them and they're still valid as complex number. We can still consider them like complex number, okay? Technically, they are just imaginary numbers, but we still use them, okay, in electronics, in alternate current. When we do exercises with alternate current, we use also this, okay? So it doesn't have necessarily to be in this way with a real part and imaginary part. It could be even just these are fine, okay? Now let's try to make the for operation with complex numbers. Let's begin with addictions. We'll do some, so we'll see some examples. Seeing some examples, I think, is the best way to learn. Making some practical example. Let's say we have 10 plus j11, okay, this is a complex number, plus another complex number, 2 plus j6, okay? So we have a complex number plus a complex number. How can we do this? Well, in this case, I can just rewrite all of this in this other way. Well, these two stays the same. 10 plus j11, and here positive and positive. Okay, this one remains positive, so plus 2, positive and positive, this one remains positive, so plus j6. Okay, I can write everything in this way. And now, well, now I just have to addictionate this with this. Okay, 10 and 2, result is 12, and here this with this. Okay, j11 plus j6, the result is plus j17. Okay, this is the result of this addiction. Let's make another one. 2 minus j8 plus minus 2 plus j 9. Okay, what happens in this case? Well, I can rewrite all of this in this way as a single expression. Okay, so this is positive, so these signs are not gonna change. Okay, this one, this and this are gonna stay the same because we have a positive sign here. Okay, so I can just rewrite everything without this, without. Okay, okay, what happens now? 2 minus 2, 0. Okay, so the real part is gone, we don't care, it's still fine. Minus j8 plus j9. Okay, so minus 8 plus 9, the result is plus j1. Okay, this is the result in this case. Let's do another one, maybe a last one. Minus 6 plus j11 plus 8 plus 8 minus j2. Okay, what happens in this case? Well, very simple. Let's just rewrite all of this. Minus 6 plus j11 plus 8 minus j2. Okay, the result is minus 6 plus 8 is plus 2. And here plus 11 minus 2, the result is plus j9. Okay, this is the result. Okay, so we have done 3 addictions, and it is addictions are pretty easy. Addition and subtractions, they are really easy. Now let's do subtractions. These are still very easy, just each time difficulty will increase just a bit, but not much. Don't panic, it is everything here is it's really easy. Okay, subtraction. Minus 2 plus j11 minus 2 plus j6. Okay, so what happens in this case? I can rewrite this in the same way. Minus 2 plus j11, okay? But here, I have to consider this. There is a minus here, so minus and minus. This one will become positive, okay? So plus 2. Minus and plus, this one will become negative. So minus j6. Well, the result here is minus 2 plus 2, 0. And plus 11 minus 6. Okay, plus 11 minus 6, so plus j5. This is the result in this case. Let's do another one. Minus 8 minus j12 minus 11 plus j 8. Okay, what happens in this case? I can rewrite this in the same way. Minus 8 minus j 12, and here minus m plus. This becomes negative, so minus 11 minus m plus. This becomes negative, so minus j 8. Okay, now what happens? Minus 8 minus 11. Okay, they are both negative, so they go together. So minus 19. Okay, and here minus 12 and minus 8, they are both negative, so they can go together. The result is minus j 20. This is the result. As you can see, subtractions are very easy too. Okay, nothing difficult. Now let's do should I do another one? Okay, I'll do another one, just or maybe not. Yes, maybe not. Let's go with multiplication. Okay, multiplications with complex numbers. 2 plus j 4. Okay, 2 plus j4 multiplied for 3 plus j6. Okay, let's do this. How can we do this? How we do multiplications with complex numbers? It is still very easy. This is just basic math. Okay, if you remember the equations, well, this is just basic math. The first thing you do is this. This one will be multiplied for this and then for this. Then this one will be multiplied for this and then for this. I'll show you. The first thing we're going to do is 2 multiplied for 3. 2 multiplied for 3 is 6. Then we are going to multiply 2 for j6, and the result is 6 multiplied for 2 is 12. Okay, and j remains. Okay, so it's plus j 12. Okay, this one multiplied for this, the result is 12 with a j, plus j12. Then plus j4 multiplied for 3. Okay, the result is still 12. Okay, and with a j, because there is a j here, so is plus j 12. And here something happens. Okay, something a little maybe strange the first times. Okay, but here something happens, something unusual happens. Well, here we are multiplying j for j. J is square root of minus 1, as you already know. Okay, so here we are doing this. Okay, the number is positive because positive for positive. Okay, the number is positive, but we are doing this. Square root of minus 1 multiplied for square root of minus 1. Okay, this is j multiplied for j, and then there is 4 multiplied for 6. Okay, 4 multiplied for 6, forgive me, but I don't remember. Okay, 24. Okay, so it's 24. Okay, so this is what we have now. And we have this. What happens now? Well, first let's do this. Okay, here we have 6 plus j12 plus j12. The result is plus j 24. And here what happens? Well, square root of minus 1 multiplied for square root of minus 1, it is like doing this. It is like doing square root of minus 1 squared. Okay, so what happens? Well, you can just simplify this with this, okay? So there is no more square root. It is just minus 1. Square root of minus 1 multiplied for square root of minus 1 is minus 1. All of this is minus 1, okay? So it's plus, all of this is minus 1, so minus 1 multiplied for 24. Okay, this is the result, okay? So here we have 6 plus j24, and here what happens? What happens here? Well, we have minus 1 multiplied for 24, so the result is minus 24. Okay, there is a plus here, but doesn't matter, okay, because minus multiplied for plus, the result is minus. So here we have minus 20. All of this, the result of all of this is minus 24, okay? So we have this, minus 24. And this is what happens now. We have 6 minus 24. We can do the algebraic sum of these two, and the result is 6 minus 24. Okay. Minus 18 plus j24. Okay, this is the result. Okay, I hope you have understood how multiplications work. We'll do another one. I'll do another one just to make another example, okay? Let's do another one. Minus 2 plus j2. Minus 2 plus j2 multiplied for minus 3 minus j11. Okay, let's try to do this. What happens in this case? Well, let's see. First of all, I do minus 2 multiplied for minus 3. Minus for minus, the result is positive, is 2 multiplied for 3. The result is 6, okay? So we have 6. Then minus 2 multiplied for minus 11. Minus and minus, they become positive. The result is plus 11 for 2, j22. Then here we have plus j2. Again, I have to multiply plus j2 for minus 3. Plus for minus, the number is negative. Negative j, then 2 for 3, 6. Okay, then we have plus j2 multiplied for minus j11. Okay, first of all, plus multiplied minus, the result is minus. Okay, so we have minus j multiplied j. We already know that the result is minus 1. J multiplied j is minus 1. Then 2 multiplied 11 is 22. Okay, what happens here? Well, we have 6 plus j plus 22 minus 6. Okay, so we have plus, okay, 16. Okay, 6 plus j16. And here what happens? Well, here we have minus 1. Minus 1. In this case we have 2 minus, and the result will be positive, okay? Because minus 1 for 22, it makes it minus 22, okay? But minus 22, negative, okay, a negative minus 22, negative minus 22 is 22, okay? So 22 is the result. And here we have plus 6 plus 22. The result is plus 28 plus j16. Okay, this is the result of our multiplication. Okay, I think it's enough for multiplication. I think you have understood now. Okay, obviously you can have a multiplication also, you know, there could be just the imaginary part, or there could be just the real part. This is still fine, you can just do it. Okay, let's do, okay, let's do another one, because maybe, you know, sometimes, okay, imagine you have 2 plus j6 multiplied for minus j2. Okay, this could happen, you could have a situation like this. And what you do in this case? Well, it is still very easy. 2 multiplied for minus j2, the result is minus j4. Okay. Then you have to do plus j6 multiplied for minus j2. Plus and minus, the result is minus. But then you have j and j, the result is minus 1. And then you have 6 and 2, the result is 12. So this is the number you have, and it is actually, here you already know, minus minus is plus, so it is plus 12 minus j4. Okay, so this is how you do multiplications with complex number. So for multiplication is enough. Let's do divisions, and we have done with this video. Okay, how can you do division with complex number? Well, let's imagine we have 2 plus j6 divided for 1 plus j2. Okay, imagine we have this situation. Well, if you have this situation, basically you cannot divide any number for a number with a j. Okay, you cannot divide a number for a number with a j. You cannot divide for this. And since you can do it, you need some strategy to do it anyway. Okay, and what is the strategy? The strategy is this. You take this division and you multiply and divide it for the same number. What is this same number? Well, you do this. You take this division and you multiply and divide it for this, but with a difference. Okay, you take this and you multiply and divide it for the same number for this, but we do this, you do this little change. You take this sign, the sign before the j, okay, you take the sign before the j and change it. Okay, if it is plus, you put minus. If it is minus, you put plus. Okay, so you do this. Okay, you multiply and divide it. You multiply this and then divide this for the same number, which is this, but you just switch this sign. Okay, if it is plus, becomes minus. If it is minus, becomes plus. Okay, you do this. If you do this thing, this strategy, you can do the division anyway, and we'll see how. Well, first of all, this multiplied for this, we do the classic multiplication we already know. So 2 multiplied for 1, it is 2, obviously. Then 2 multiplied for minus j2, the result is, you know, a negative number, j and 4, 2 and 2 is 4. Then j6 multiplied for 1 is plus j6. And j6 multiplied for minus j2, it is minus j and j, it is minus 1. And then 6 and 2, it is 12. Okay, this is what we have here. Okay, above. the fraction line. And let's see what we have below the below the fraction line. Let's see what happens below the fraction line. Okay, 1 multiplied 1, it is 1. 1 multiplied minus j2, it is minus j2. j2 multiplied for 1, it is j2 plus j2. Then j2 multiplied for minus j2, it is plus and minus. Okay, we have minus. Then j and j, it is minus 1. And then 2 and 2, it is 4. Okay, so this is what happened. Let's continue and see what we'll have. Well, above the fraction line we have 2 minus j4 plus j6. So this one becomes plus j2. And here we have minus, so plus 12, okay? This is what we have above the fraction line. Then below, what happens? We have minus j2 and plus j2. Same number, opposite sides, so they both go, okay? I can simplify it in this way. Here we have 1, and here we have minus 4, so plus 4. So 1 plus 4, okay? This is what we have here. So this is what happens, okay? And this one becomes just 12 plus 2, so 14 plus j2. And here we have 1 plus 4, we have 5, okay? So with this strategy, you can eliminate the j under the fraction line, okay? This strategy is useful to eliminate this j under the fraction line, okay? And so in the end you have something like this, and you can do this easily, okay? Here you do 14 divided 5, and the result is 2.8. And here you have j2 divided 5. The result is basically you do 2 divided 5. Okay, you divide 2 per 5. You leave the j here, and then you do 2 divided 5. 0.4. Okay, so this is how you do divisions between complex numbers. Okay, this is how you do divisions between complex numbers. Let's do another one, just to make more examples, so it is more complete. Okay, what can I do here? Let's try to do 2 plus j12. Okay, 2 plus j12 divided for minus 3 minus j8. Okay, let's try to do this division. Okay, I can't do it. Okay, the first thing you do is, okay, I can't do it, but so I have to use this strategy to do it anyway. And the strategy is, I will multiply and divide this for this number, but I will change the sign close to the j, okay? I will change just this sign. So I'll do this. Multiplied for minus 3 plus j8, okay? I do this. And here I do the same, then divided for minus 3 plus j8, okay? I changed the sign close to j. I just did this. Okay, so now let's continue, and what happens here? We have to do to calculate everything, and okay. So 2 multiplied minus 3, the result is minus 6. Then 2 multiplied j8, the result is plus j16. Then 12 multiplied minus 3, The result is 36 minus J36, okay? Then J12 multiply J8 plus and plus, it is positive. J and J, it's minus 1. And 12 and 8 is 96. Okay, so we have this. Then what happens below the fraction line? Minus 3 and minus 3. Minus 3 for minus 3. The result is plus 9. Okay. Then minus 3 for J8. Result is 24. Yes, 24. Okay, minus 3 for J8 is minus 24, minus J24, okay? Minus 3 for J8 is minus J24, okay? Now, minus J8 for minus 3, the result is minus and minus plus J24, okay? And here minus J8 for plus J8, the result is minus and plus, okay? So minus J and J minus 1 is the result. 8 and 8, 64. Okay, so this is what happens. Here we have, okay, above the fraction line we have, minus 6, and this one becomes minus 96. So the result will be, okay, 12, minus 102, okay, and here plus 16 minus 36. The result here will be minus J20, okay, and here below the fraction line we have minus J24, then plus J24. So these two, they go away because they are the same number, different sign, so they go away. Here we have plus 9, this one becomes minus and minus, this one becomes positive, so plus 9 plus 64, okay? So we have 73. Okay, this is what happens, okay? So now we can easily do it. We just have to divide this for this and then this for this. Okay, so we have this minus J, okay, minus 1.39 minus J, 0.27. Okay, so this is the result. This is how you do divisions between complex numbers. Let's try to do a last example, okay, just the very last, the last one, okay. 2 minus J 2, okay, divided for J 2, okay, very simple one, okay. What can I do now? I just have an imaginary number here. Well, what I do is exactly the same. I multiply and divide all of these for this, but I just change the sign here, okay? It is plus J2, this is plus J2, so I do minus J2, and here I divide for minus J2, okay? I do this. Now, let's calculate everything. Let's see what happens. Well, above the fraction line, 2 multiplied for minus J2, the result is minus J4, okay? Minus J2 and minus J2. Minus and minus, the result is plus. J and J, the result is minus 1. 2 and 2, the result is 4, okay? What happens here? We have minus J2, we have J2 multiplied minus J2. So plus and minus, the result is minus. J and j, the result is minus 1. 2 and 2, the result is 4. Okay, so this is what happens. And let's continue. Here we have minus j4. And here we have plus and minus. It is minus 4. Here we have minus and minus, so plus. So the result here is plus 4. Okay, so here we have minus j4 divided for 4. Okay, 4 and 4 it is 1. So minus j1. And here minus 4 divided for 4. It is 1, but minus and plus, so it is minus 1. This is the result. You can write in this way if you prefer, minus 1 minus j1. Okay, it's the same, but okay, this is the result. Okay, we have done all the 4 operations with complex numbers. I hope that everything is clear enough in this video. I hope that you have understood everything I explained. And if you have any questions, feel free to ask me in the comment. I'll do everything possible to answer you. Okay? But I hope this explaining this, okay, this, everything was clear enough. I hope it was clear enough. Yes, but if you have questions, okay, do it in the comments. I'll respond. Okay, for this video I think is enough. We can close it here, and okay, so I hope you like it, and see you in the next video. Okay.